All right, today we are starting chapter 5. We're doing 5.1, multiplying polynomials. Okay, so our objectives are to multiply polynomials and to use patterns to simplify special products of binomials. All right, so hopefully you remember what a polynomial and a binomial are. Remember, like this is a monomial, it's just one term. A binomial has two terms, so maybe we have 2x plus 2. So now that's a binomial because there's 2. Or maybe we have minus 3x squared. This is a polynomial. We have more than 2. Technically, it's a trinomial because there's 3 terms. Okay, so those are the terms that we're looking for when we're looking at those. Now, one thing, if you had like 2x plus 2 plus 3x, okay, these two could be combined, right? And that would be 5x plus 2. Those two can be combined into a binomial. These cannot be combined because they're different terms, right? We have an x term, no term at all, right? There's no variable, and then an x squared. All right, so we're going to look at multiplying those. To do this, we're going to use the distributive property to multiply a monomial and a polynomial. So the 2x here is the monomial. The 5x squared plus 3x minus 7 is the polynomial. And we distribute. So 2x times 5x squared. So 2 times 5 is, good, 10. X times x squared is x cubed. Excellent. 2x times 3x. Well, we're going to do 2 times 3, and it's a positive, so it's going to be a positive 6. X times x is x squared. And 2x times negative 7. So 2 times negative 7 is negative 14, and x times no term just gives us x. And that's it. We're finished. Okay, we just multiplied those polynomials or distributed them. Okay, it's going to get a little more complicated when we have more than just a monomial. So the monomial to anything is the easiest. Now, we're going to use the distributive property repeatedly to multiply two binomials. Okay, so if we look at that, we have this term called FOIL. That's going to help us. So first, outer, inner, and last. And what that means is we're going to multiply the first terms. So we're going to multiply a times c. So it's the first term in each set, right? We have a and b grouped together and c and d. Okay, so we're going to multiply the first terms in both of those. Let me erase some of that red. Then we're going to multiply the outer terms, so a and d, because a is on the outside and d is on the outside. So the two terms on the outside. Then we will multiply the inner terms. So that's going to be b and c. We'll multiply together because they're on the inside. And the last terms are going to be b and d. b is the last term in that first binomial, and d is the last term in the last binomial. So first, outer, inner, last. Okay, so this shows it a little more. We're going to do a times c and a times d. So we're distributing the a to the c and the a to the d. And the second one, we're distributing the b to the c, and we distribute the b to the d. However, that helps you think about it. So we're going to end up with the quantity of a times c plus the quantity of a times d plus the quantity b times c plus the quantity b times d. And remember, don't forget to combine like terms to simplify your answer. Okay, so we're just going to jump in example 2 here. So we're going to multiply the first terms together. So 3x times x is 3x squared. I'm going to color code this. Maybe I should have done the same colors I did before, but that's okay. So then that was first. Maybe I should label that our first terms. Then we're going to go with our outer terms, so the terms on the outside. So 3x times negative 5. 3 times negative 5 is negative 15, and x. Then we're going to do our inner terms, so the terms on the inside. So 2 times x, these are our inner terms. So that's going to give me a positive 2x. And our last terms. So the last term here and the last term here. 2 times negative 5 is negative 10. Then I remember to combine my like terms. Okay, so what are my like terms? Excellent, the negative 15x plus 2x. So this is going to give me 3x squared. Negative 15x plus 2x is negative 13x, and then minus 10. That is our polynomial answer, okay, because I have an x squared term, I have an x term, and then I just have a constant with no variable there. If you do these in order, like FOIL, if you do it in order like this, it's always going to be these middle two terms that should be combined. I shouldn't say always. Like 90% of the time, it's going to be those first two terms, or those middle two terms that you combine. All right, so let's tackle B. So our first 5x times 2x is 5 times 2 is 10. X times x is x squared. Our outside terms, 5x times a positive 3y. So 5 times 3 is 15, and I have an x times a y, so I have xy. Totally fine. All right, my inner terms, negative 3y times 2x. Negative 3 times 2 is negative 6. Okay, I have y times x. I'm going to go ahead and put them in alphabetical order, x, y. So it's easier for me to see the like terms. And my last ones, right? Negative 3y times a positive 3y. Negative 3 times 3 is a negative 9. Y times y is y squared. I look for like terms. And again, they're right here in the middle. So I'm going to have 10x squared. 15 minus 6 is going to give me a positive 9xy minus 9y squared. I don't have any more like terms to combine, so that's it. All right, great. So hopefully that's not too bad learning this FOIL method. You might have seen it previously, but we're going to be using it a lot. Then, okay, moving on, we're going to use vertical multiplication to multiply polynomials with more than two terms. Okay, so notice here we have a binomial times a trinomial. And what this means by vertical multiplication, okay, is we're going to set it up just like vertically, like we do old school multiplication, multi-digit. So notice we took the longest term and put it on the top, so 9a squared plus 4a minus 7. And we put our shorter polynomial on the bottom, the 6a minus 2. We take one term, so in this case negative 2, and we multiplied it by 7 and got negative 7 times negative 2 is a positive 14. And then we multiplied negative 2 times a positive 4a. Negative 2 times positive 4 is negative 8a. And then we did negative 2 times a positive 9a squared. Negative 2 times 9 is negative 18a squared. All right, well, just like your typical vertical multiplication, we have to keep going. Okay, so this time we're going to pick up our 6a and multiply it by each of the terms. Now, remember, since we've moved over, you can put a 0 in this space, you can put an x for a placeholder, whatever you need. Maybe I'll put a box around it and an x so you know it's not the variable x. But we have that placeholder there. We need to move over one. So 6a times negative 7, don't forget that negative. 6a times negative 7 is going to be negative 42, right? A. You're going to love how this matches up because then we have the a's in the same column. It's going to be much easier to add them later. 6a times a positive 4a. 6 times 4 is a positive 24. A times a gives me a squared. So notice again, we have our like terms in a column to add them. And the last one, 6a times 9a squared. 6 times 9 is 54, and a times a squared is a cubed. All right, so we've done the math, and then what do we do? In vertical multiplication? Yeah, we add, right, those together. So we're adding our like terms. 14 plus nothing is 14. I'm going to make my 4 like that just to be fun. It's positive. Negative 8, okay, plus a negative 42. Negative 8 plus negative 42a is negative 50, right? So we got negative 50a. Then we've got negative 18a squared plus 24a squared. Well, negative 18 plus 24 is going to give me a positive 6a squared. And then we just have the 54a cubed. So 54a cubed. That is our answer. Okay, so just doing some vertical multiplication there. Okay, so let's try B, example B here. So remember, take your longer polynomial. You also do want it in descending order, like x squared, x, and no variable, right? Sometimes, like, that's just to be expected. And then we're going to line up our binomial under that. So my 2x minus 5. All right, so let's start with our negative 5. Negative 5 times negative 4 is, good, positive 20. Negative 5 times x is, excellent, negative 5x. Negative 5 times 3x squared is, very nice, negative 15x squared. So let's move over to our 2x term. 2x times negative 4 is, okay, I'm going to put my x in here before I forget, my placeholder. Let me ask that again. 2x times negative 4 is, good, negative 8x. 2x times x, excellent, is a positive 2x squared. And 2x times 3x squared, good, is a 6x cubed. All right, then we're ready to add these together. All right, so 20 plus nothing is 20. Negative 5x plus negative 8x is going to give us a negative 13x. Sorry, let me put my plus in there for that positive 20. I don't want to lose it. Okay. Then negative 15x squared plus 2x squared. Good. Negative 13x squared. And 6x cubed plus nothing is 6x cubed. So there we have it. 6x cubed minus 13x squared minus 13x plus 20. Good work. Okay. Next up, we have some really, really important patterns. Okay. It says remember patterns. Okay, you want to remember these. Like, you will need to memorize these. It will make your life much easier if you can memorize these. Okay, so there are several special binomial products. Notice it's binomials, right? So when we have a plus b and a minus b, forms are called conjugates. Okay, so a plus b and a minus b. Notice that the only difference is the addition and the subtraction. And those are called conjugates of each other, right? One is adding, one subtracting. That's it. So our special products are called the product of conjugates. So when we're multiplying a plus b and times a minus b, we get a squared minus b squared. Okay, so like if I were to put numbers to this, say I had 2 plus 3 times 2 minus 3. What that's saying is this is going to equal, if I do all the math out and FOIL and all the work, this is going to be equal to a squared. So our a value was 2. So it's going to be equal to 2 squared minus our b squared. and our b is 3. So it's going to be equal to 2 squared minus 3 squared, which would be 4 minus 9, we would see. Okay, which we would work down to 5, but we're looking at binomials and things. Like, we're not going to take it this far. But when we see square numbers, that's going to be helpful for us. Then we have the square of a sum. Okay, you know that sum is addition, and you know what square is. So this is when we take the sum form, a plus b, where we're adding, and we square it. Okay, that's going to give us a squared plus 2ab plus b squared is the shortcut. So you can skip FOILing and all those things. Now, do you have to do it this way? No, but later we're going to be given problems in this form, and you're going to have to work backwards. So memorizing these 3 special products is going to be very helpful for you. The last one we have is the square, because we're squaring a quantity, of a difference. Okay, so this time is when we have the quantity a minus b, and we're squaring it. Notice in this case we have a squared minus 2ab plus b squared. The only difference in the sum of squares and the difference of squares is that first operation. In the sum of squares, we're adding a squared plus 2ab. In the difference of squares, we're subtracting a squared minus the 2ab. Okay, so with that being said, example 5, we have an a, b, and a c. We're going to apply each of these special products of binomials. Okay, so the thing to do here is we can look and see and recognize this, like 3y plus 5, 3y minus 5. You should have like light bulbs going off when you see, that's a terrible looking light bulb. But you should have light bulbs going off when you see like, oh wait, these are the same, 3y and 3y, 5 and 5. There should be a light bulb there that's going off, so you know like, hey, this is a shortcut. All you have to do then is identify which term is a and which term is b. So here, 3y is your a term and 5 is your b term, because you know that this is going to go to the a squared minus b squared. That's your shortcut. Okay, so I'm going to take the a value, which is 3y, and square it. And then I'm going to subtract my b value, which is 5, and I'm going to square it. Okay, remember when we have this, right, we have the quantity, the square applies to each part. So 3 squared is 9, and then y squared is y squared. Minus, because the negative here is not included, we're just squaring the 5, so 5 squared is 25. Now again, I could do out all the work and FOIL that and get the same thing. Okay, so 3y times 3y is 9y squared. 3y times negative 5 is going to be negative 15y. 5 times 3y is going to be a positive 15y. And 5 times negative 5 is going to be a negative 25. I have like terms right here, negative 15y plus 15y, that cancel. So I am left with 9y squared minus 25, which is exactly what my shortcut told me was going to happen. Okay, that's what I want you to see, is these are truly a shortcut. You can skip all the FOILing work if you have it stored in your brain. And if you forget it, you know how to go back and do it. Okay, so then let's try B. Which pattern does B meet? Good, B is the square of a sum. Okay, so again, our A term is 3y, our B term is 5 here. So we're going right here for this one. We're going to have a squared. So 3y is the term. We're going to square it. Plus 2 times a, which is 3y, times b, which is 5, plus b squared. Our b is 5, so plus 5 squared. Which you may think is not a shortcut, but I promise you it is. So 3 squared is 9, y squared is y, plus 2 times 3 is 6, 6 times 5 is 30, and then we have y in there, plus 5 squared is, excellent, 25. Oh, I forgot my y, the squared on the 9y there. So we have 9y squared plus 30y plus 25. Awesome. Let's look at C. Which special product does it match? The square of a difference, right? We have a difference here. So it's our A is 3y, our B is 5, okay, because we're matching, this already has a minus, so the B is just the 5 here. You don't take the minus sign as it, because the minus sign is accounted for in the formula, okay? That's the one tricky thing that you do have to remember with the formulas. All right, so this matches that A squared minus 2AB plus B squared, okay? Maybe it'll be better if I write it there. Our A is 3y, so we're going to take 3y and square it, minus 2 times our A term, which is 3y, times our B term, which is 5. And you might already see a pattern here. I wouldn't be surprised. But plus our B term, which is 5, and we square it. So 3 squared is 9, y squared is y squared, minus 2 times 3 is 6, 6 times 5 is 30, so we have minus 30y, plus 5 squared is 25. Okay, so you might have noticed, like, these are going to be the exact same terms, Mrs. Talbert, right? Like 9y squared, 9y squared. 30y, it's a plus instead of a minus, but they're the same term. And 25 and 25. Again, you probably noticed it. That's perfect. Okay, that is it for today. Make sure you work on, like, being aware that you're going to want to memorize these special products of binomials this week, or, well, this chapter, because they'll come in handy this chapter and after. All right, have a great one.